Session 8.3 Solving linear equation to make predictions. Example, using the distributive law to help solve an equation. So I want to solve the equation. First, I have the equal sign here. So I know this is an equation, and solve means I'm looking for the variable. I have the variable a in here. So I'm looking for what is my a in this equation. So what we're gonna do, we're gonna use the distributive law on each side. So make sure when you distribute, you're gonna distribute the -2 in here. Okay, so you have a -2 times a, that'll be -2a, negative, you're gonna get positive. So plus 6 in here. And then plus 4. Here, 4 times a, you're gonna get 4a. 4 times -2, you're gonna get -8. Now combine the 9 terms. On the left hand side, I do have a 2 constant. So I could combine the 9 terms on the left hand side. So that will be -2a plus 10. And then I want to combine the 9 terms of the variable a in here. So here I'm gonna subtract the 4a for both sides. And you can see -2a minus 4a, which is going to be -6a. -6a plus 10. And here, 4a minus 4a, you're going to cancel out. So I only left with the -8. Okay, now I want to isolate the -6a here. So I'm going to subtract 10 for both sides. So here, I'm going to cancel out. I left with -6a equal to -x minus 10. So that'll be -18. And then I want to get out of my -6 in here. So since this is a multiplication, I'm going to do the division. I'm going to divide it by -6 for both sides. So cancel out here. Negative, you're going to get positive. So a will be equal to 3. Okay, after you solve the equation, you find the variable equal to a number. Now, I want you guys check your work. Plug in back a equal to 3 to the original equation here. Okay, check your work. Plug in back a equal to 3 here. 3 minus 3, you're going to get a 0. Okay, 0 times -2, you're going to get 0. It's plus 4, so you only have the 4 in here. On the right hand side, 3 minus 2, you're going to get the 1. 4 times 1, you're going to get the 4. So this is the true statement. So you know a equal to 3 will be the solution of this linear equation. Clearing fractions. A key step in solving an equation that contains fractions is to multiply both sides of the equation by the LCD, so that there are no fractions on either side of the equation. When you guys working on solving equation involving the fractions, first step, you want to find out the LCD. After you find out the LCD, you want to multiply the LCD for both sides. So after you multiply the LCD, you shouldn't get any fractions of either side of the equation. So let's try this example. So I want to solve this equation involving the fractions, right? I have a fractions in here. So first step, I want you guys find out the LCD of 3, 6, and 4. Okay, all the denominator here, 3, 6, and 4. Find the LCD. So I'm gonna find out the multiple of 3, multiple of 6, and multiple of 4. For the first one, multiple of 3, I have a 3, 6, 9, 12, 15, 18, 21, and so on. Multiple of 6, I have a 6, 12, 18, and 24. Last one, 4, 8, 12, 16, and 20. I just list all the multiples with the denominator. Now I'm gonna find out which one will be the smallest common denominator, which is going to be 12, right? So my LCD, that's equal to 12. So this is going to be the first step. Find out the LCD. And we are not done yet. Okay, keep going. So now we're going to multiply the LCD to create the fractions. Okay, I don't want to deal with the fractions. So what I'm going to do, I'm going to multiply 12 for both sides. On the left-hand side here, I'm going to put the parentheses. So make sure you're going to distribute the LCD one by one here. Okay, so here, simplify before you multiply. I have 12 divided by 3. I'm going to get the 4 here. 4 times 2, you're going to get the 8. 6 and 12, you're going to get the 2 here, right? So 8x plus 2 equal to 12 divided by 4, you're going to get 3. 3 times 3, that will be equal to 9 here. And then I want to isolate my x, so I'm going to subtract 2 for both sides. And that will be 8x equal to 7. And then divided by 8 for both sides, you're going to get x equal to 7 over 8. Okay, check your word. Plug in x equal to 7 over 8 into the original equation. So here, simplify before you multiply. This is 1, this is going to be 4. Right? 4 times 3, you're going to get the 12. So 7 over 12 plus 1 over 6 equal to 3 over 4. And then I want to add up these two fractions, and they don't have the same denominator, right? What is the LCD for these two guys? That will be 12, right? So I need to multiply by 2 on the denominator and multiply by 2 on the numerator. So now they're going to get the same denominator. So 7 plus 2, which is going to be equal to 9. Simplify this guy. 3 over 4 equal to 3 over 4. So this is going to be the true statement. So the solution is 7 over 8. Okay, look at this example again. When we want to solve the equation involving the fractions, first step, find out the LCD. And then you want to multiply the LCD for both sides. If you have more than one term, you may want to put the parentheses. After you multiply the LCD, you shouldn't get any fractions for either both sides. If you still have the fraction, means you make a mistake either finding the LCD or for the multiplication here. And then just solve the equation just like the previous session. For the exam, you don't have to show me your check here. Okay, this is not part of your credit, but I highly recommend you guys do it on the scratch paper. Make sure you get the correct answer. Results of simplifying an expressions and solving an equation. Many students get confused about like these two parts, simplifying an expression and solving an equation. What is the difference between these two? For example, if I want you guys simplifying an expression, you should see the questions like this. The expressions means they don't have the equal sign here. Okay, this is not an equation. Expressions, they don't have the equal sign. Simplify means I want you guys combine the 9 terms. So here 3x and 2x, this is the 9 terms. So I subtract it, I only get 1x. 6y and 7y, this is the 9 terms. So I add it up, I'm gonna get 13y here. So this is gonna be my final answer. I won't be able to find out what is my x or what is my y here. So this is means simplify an expressions. And solving a linear equation in one variable is a number. So for example, I want you guys solve this equation. First, when you guys see the equal sign, this is an equation. And solve means I'm looking for my x. I want to know what is my x equal to. Okay, so this is just like the balance. I'm gonna subtract 2 for both sides. And then I find out x equal to 1. For solving equation, I should be able to find out what is my variable equal to. And this variable should be equal to a number. Simplifying in expressions, it means combine the 9 terms only. I won't be able to figure out what is my variable equal to. Okay, example, comparing expressions and equations. So, number 1, simplify. Again, you don't have the equal sign. You know this is expressions. Simplify means I want you guys combine the 9 terms. So I do have the x here and I do have an x in here. So these two guys are the 9 terms. So first step, I want you guys find out the LCD. 5 and 3 LCD will be 15. Okay, so LCD equal to 15. What do I need to multiply to get the 15 here? I'm gonna multiply by 3 here, multiply by 3 here. This one, I need to multiply by 5, multiply by 5 here. Okay, so multiply it, you're gonna get the same denominator. And I know this is the 9 terms, so I could just add up the numerator. 6x plus 5x, which is gonna be equal to 11. 11x over 15. So simplify, just combine the 9 terms. My final answer, I may still have the variable in here. Okay, number 2, solve the equation. That's an equal sign here. And I want you guys solve. Means I'm looking for my x. What is my x equal to? And this time involving the fraction. So first step, find out the LCD with 5 and 3, which is gonna be 15, right? Same idea with this one, right? LCD equal to 15. Now, I'm gonna multiply the LCD for both sides. And since I do have 2 terms in here, so I'm gonna put the parenthesis and distribute the 15 here. Okay, simplify 1 by 1. This is gonna be 1 here, 3 here. 3 times 2, you're gonna get the 6. 6x plus 15 divided by 3, which is gonna be 5, right? So 5x equal to 12. Okay, combine the 9 terms, which is gonna be 11x equal to 12. And then divided by 11 for both sides. So x equal to 12 over 11. Okay, I want you guys compare the expressions and the equation. For the expressions here, we want to combine the 9 terms. And my final answer, I'm involving the variable in here. But solving the equations, that's an equal sign in here. And then we can multiply the LCD for both sides here. And at the end, you should be able to find out what is your variable equal to. Okay, example, solving an equation in one variable by graphing. From the previous sessions, we learned how to solve an equation by graphing. Remember that? For example, I have these 2 linear equations. This is y equal to mx plus b. Okay, I use the blue line to represent this linear equation. Y equal to negative 1/2 x minus 1. And another one, y equal to negative 5 over 4x plus 2, which is going to be the red one here. I want you guys to use the graph to solve the equation. Okay, so you could see negative 1/2 x minus 1, which is going to be the blue one here. and equal to negative 5 over 4x plus 2, which is going to be the red one here. So since this is equal to each other here, I want you guys find out the intersection. What is the intersection for these two equations? That will be 4 and negative 3, right? The two lines intersect only at 4 and negative 3. And then we are looking for the x. What is my x equal to? So gonna look at the x coordinate. X coordinate, that will be equal to 4, right? So I know 4 will be the solution of this equation. You could double check your work, plug in x equal to 4 here. You should get the true statement. Solving an equation in one variable by using the table. The solution of y equal to 2x minus 5 and y equal to negative 4x plus 13 are sorted in the table 4 and 5. Use the table to solve the equation. So this example is really similar to the previous one. Instead, they didn't give you the graph. They give you guys two tables of the solutions. And you can see from these two tables, we only have a one same coordinate, which is going to be 3 and 1 here, 3 and 1 here, right? Think about it. This one, the 3 and 1, it just looks like the intersection point in here. So 3 and 1 is the intersection point of these two equations. And then we are looking for the variable of x. So my x is going to be equal to 3. So let's try to plug it in here. Plug in 3. I have 3 times 2, 6. 6 minus 5, which is going to be 1. Negative 12 plus 13 is also equal to 1. And this is going to be the true statement. So I know the x coordinate equal to 3, and 3 will be the solution of this equation. Using an equation to find an output and an input. So I have the function of x equal to 3 over 2x minus 1. Number 1, I want you guys find f of 4. Okay, f of 4 means I want you guys plug in x equal to 4 into this equation. Okay, simplify it. This is going to be 2 times 3, 6 minus 1, which is going to be equal to 5. So when x equal to 4, y will be equal to 5. Okay, one more time. When x equal to 4, y will be equal to 5. Okay, next one. Find x when f of x equal to negative 4. This time, I'm looking for my x here. I want to know what is my x equal to and get y equal to negative 4. Okay, so plug it in. Function x equal to 3 over 2x minus 1. And I have an equation here. I want you guys to solve the equation. So this equation involving the fraction. I want you guys to find out the LCD with 2, 1, and 1. Okay, that's a denominator 1 here, denominator 1 here. So the LCD is going to be 2, right? Now, I'm going to multiply by 2 for both sides. Make sure you're going to distribute the 2 one by one. Okay, cancel out. So I have a 3x minus 2 here. And this is going to be negative x. Okay, now I want to get out of the negative 2. So I'm going to add 2 for both sides. Okay, you're going to get 3x minus 6. And then divided by 3. X is going to be equal to negative 2. So this means when x equal to negative 2, y equal to negative 4. using an equation of a model to make the prediction. So we want to use the linear equation as the model to make the prediction. So the linear equation, I could use y equal to mx plus b. Remember we say for the association, we do have explanatory variable and also the response variable. So response variable is talking about the y here. Explanatory variable, this is talking about the x. So here it say, when making a prediction about the response variable, if you guys want to find out what is your y here, you're gonna substitute a chosen value for the explanatory variable. So you want to plug in for your x and then figure out what is my y in here. If you want to make a prediction about the explanatory variable, if you want to find out what is your x, you're gonna substitute a value for the y here and then solve for your x. Okay, example, using a model to make an estimate. The sales of musical instruments were 6.39 million in 2010, and they decreased by about 0.28 million per year until 2014. So this means like every year they will be decreased 0.28 million until 2014. Estimate in which year sales were 5.3 million. So first, we're gonna let S be the annual sales in millions of dollars and T years since 2010. Remember I say when you have this guy, T years since 2010 means T equal to 0 when year 2010. So if you have a 2014 means T equal to 4 when year 2014. And we have the S and the T variables. So think about it. Which one will be your response variable? Which one is going to be explanatory variable? We usually put the year on your x-axis, right? So the S, the annual sales, is going to be on your y-axis, meaning that the S here, that will be your response variable. The T here, that will be the explanatory variable. And then we're going to let the linear equation be the model. We're going to let S equal to mt plus b, just like the y equal to mx plus b, right? So my S will present your y here. Your t will present your x in here. Okay, the first sentence here, the sales of musical instruments were 6.39 million in 2010. This means when t equal to 0 in year 2010. The sales of the musical instruments were 6.39 million. Okay, so if you plug in this information into this equation, you're gonna find it out 6.39. That will be your S-intercept. Okay, your B will be equal to 6.39 when t equal to 0. And because the sales decrease about a constant 0.28 million per year. So every year they're gonna decrease 0.28 million. So we know this is gonna be the slope. And I have the negative because this is a decreasing, okay? Keep decreasing every year. The slope will be negative 0.28. So we have these two information. We could plug in back to my model. And I find out the linear equation for this model, which is S equal to the slope negative 0.28t plus the S-intercept 6.39 here. Okay, after we figure out the linear equation, we're gonna estimate which year sales were 5.3 million. So they're given the S. And I want you guys find out the T here, which years. So plug it in, S equal to 5.3. And then solve for your T here. So here I'm gonna isolate the T. I'm gonna subtract 6.39 for both sides. You're gonna get this one. And then I'm gonna divide by negative 0.28 for both sides. So negative, negative, you're gonna get positive. You should approximate get 3.89. And this is represent your t, right? Now we need to figure out which year when t equal to 3.89. So t equal to 0 since 2010, 2010 plus 3.89. You should get 2013.89. So we rounded up, it's about like 2014. So year 2014, the sales of the musical instruments were 5.3 million according to the model. That's it for the session 8.3.